Here we're being asked to differentiate the given function, and then they always throw in with respect to x. Remember, differentiate, that term just means take the derivative of, and then with respect to x, it's just telling us what variable we care about. So we are looking at this equation, e to the 3x squared minus 8x plus 5. When you see an e in a problem, really this is what I refer to as a special case derivative. There's just certain derivatives that you have to have memorized. If you have them memorized, they're no problem. If you don't have them memorized, you're never going to guess them, right? So if our special case is e to the x, the derivative of e to the x is e to the x. The key with all of these special cases, it's always the same. You've got this base case here, but as soon as I change that x that you start with to anything more than just a basic x, negative x, 3x, as soon as it is more than just that basic x, we are looking at a chain rule problem. So the majority of these special cases that you run into are going to end up being chain rule problems because they're very rarely going to be just an x sitting inside there. Looking back at our problem, we can see that we definitely have something more than just an x going on inside our e right there. So we know that we're going to be looking at a chain rule. So my chain rule recipe that I use goes d in times d out. The derivative of whatever is inside that function, whatever replaced that basic x inside there, times the derivative of the outside of the function, which will just follow our special case. So looking again at our specific problem, whatever replaced that x is our inside piece. So looking at that as just its bite-sized little math problem here, we get 3x squared minus 8x plus 5. Take the derivative of that, the d in, that's what I mean by d in, derivative of the inside. And now what we're going to do is we're just going to follow our standard power rule. Really, most of these derivatives end up always flowing back through the power rule. And the power rule saying that I use just says bring the power down and then subtract 1 from the power. So doing that in this situation, we would bring our power down. So we're going to bring this 2 down. We get 2 times 3 gets us 6x, and then subtracting 1 from the power gets us x to the first. There's an unwritten 1 on that x, right? So we bring that down, multiply it by the negative 8, and we get negative 8. Subtracting 1 from the power is going to get us x to the 0. And as we've talked about on a lot of these, anytime anything to the 0 power is always 1. So we get negative 8 times 1, which is just negative 8. And then the derivative of 5, the derivative of a constant, is always 0. So we have our d in, and now we're going to go find our d out. So the outside piece is this e function. It's going to follow this special case like you would expect it to. So right now on the outside, we have e to a bunch of junk, and all that junk is just the same inside stuff untouched here. And then to take the derivative of that, we just follow the rule. The e derivative is the easiest derivative you'll ever take. It just stays the exact same. So the derivative looks just like the starting equation for the outside. Now that we've got the d in and the d out, we've got what I call the ingredients. We've got everything we need now to follow our chain rule recipe. So to put together our derivative, our f prime of x, we just follow this recipe. So the recipe says go grab the derivative of the in. So we go grab the d in. And then we're just going to multiply that by the d out, the derivative of the outside piece, which is this e to the 3x squared minus 8x plus 5. And that's it. No more simplification. You're done. Walk away. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.